Hello guys, this is Edukant International. Okay, so we are going to be looking at this chemistry practical question. Okay, so A is a solution of triazonitrate 5 acid of unknown concentration. Okay, and B is a standard solution of sodium hydroxide containing. So this is the concentration in gram, that is 4.00 gram per dm cube of solution. 25 centimeter cube portions solution B of solution B. Required an average of 24.00 centimeter cube of solution A for neutralization. So this is a neutralization reaction. So using 2 drops of methyl orange, write a balanced equation for the reaction. Calculate the concentration of solution B. Solution B is our sodium hydroxide in moles per dm cube. Calculate the concentration of solution A in moles per dm cube. Calculate the concentration in grams per dm cube of triazonitrate 5 acid in solution A. Okay, so this is our question. So let's go into the solving. Okay, so for the balanced equation, okay, so we have that our solution A, the acid HNO3 we are reacting it with sodium hydroxide. Okay, so this will give us, we know definitely, sorry, this will give us water and salt. Okay, so our water here is H2O, and then our salt is going to be NaNO3. So this is triazonitrate 5 salt. Okay, so now from here we see that the equation is also already balanced. So we have one mole of sodium, 1 mole of nitrogen, 3 moles of, so that's 4 moles of oxygen, and then 2 moles of hydrogen, so which is the same thing here, 2 4 1 1. Okay, so from there, that's our balanced equation. Okay, so HNO3 plus sodium hydroxide we give water plus NaNO3. Okay, so B, you say calculate the concentration of solution B in moles per dm cube. Okay, so the molar, you know that moles per dm cube is molar concentration. Okay, so molar concentration, that's mole per dm cube, we give mass concentration divided by molar mass. Okay, so for any substance, for any chemical, okay, we have that molar concentration we give mass concentration over molar mass. Okay, so where mass concentration is gram per dm cube and molar mass is gram per mole. Okay, so in this equation we are looking for B, and our B solution B from here is B is a standard solution of sodium hydroxide. So we are looking for sodium hydroxide, we are looking for the molar concentration. Okay, so this is unknown. So for sodium hydroxide, we know that the mass concentration is 4.00 gram per dm cube. Okay, so that's 4.00 gram per dm cube. Then for the same sodium hydroxide, the molar mass is, so add for the mass of sodium, that of the molar mass of sodium, oxygen and hydrogen. Okay, so that of this we know from our periodic table is 23 plus that of oxygen is 16 plus that of hydrogen is 1. So everything here will give us 40 gram per mole. Okay, so now our molar concentration now is what? Mass concentration per molar mass. So therefore means our molar concentration which we are looking for a mole per dm cube is 4 divided by 40. So this will give us 0.1 mole per dm cube. So this is our molar concentration for this for sodium hydroxide. Okay, so now you calculate the concentration of solution A in moles per dm cube. Okay, so the solution will be concentration of A in moles per dm cube is unknown. Okay, but we know our volume of A to be 24 cm cube, and then our number of moles for A from our equation to be 1. Okay, to be 1, yeah. So this A, this B. Okay, so this will be 1. So our C for base is 0.1. Remember, it's in mole per dm cube. Then our volume of base is 25 cm. And then our number of this will be 1. Okay, so we are applying the equation CA VA over CB VB equal to NA over NB. So our CA from here will give us CB VB NA over VA NB. Okay, so substituting all our values inside, so we have 0.10 as our CB in mole per dm cube times 25 cm cube times NA 1 over VA 24 times 1. Okay, so it's important for us to know that yes, it's cm cube, yes, in cm cube, but our volume here, which is here, is in dm cube. So it won't affect this thing because the cm cube and the cm cube here will cancel out. Okay, so that's division. So they'll divide out. So our CA, so if we multiply this together, give us 0.1042 mole per dm cube. Okay, so now so that's for our C. Okay, so now going to D, we calculate the concentration in gram per dm cube of HNO3, our A. So we've calculated the moles per dm cube for A, moles per dm cube for B. Okay, now we are looking for the gram per dm cube for A. Okay, so we are going to be using the equation we used in our first lesson. So this equation now we are going to apply it. So we are looking for now, we are looking for the mass concentration, which is gram per dm cube. Okay, so we already know our molar concentration. Okay, and then we can find our molar mass. Okay, so we are going to be using this equation. Okay, so from this equation we'll have that mass concentration is going to be equal to molar concentration times molar mass. Okay, so we are looking for the molar mass of A. So molar mass of A, that is HNO3. Okay, we are looking for the molar mass of HNO3, or which is A. Molar mass is gram per dm cube. Okay, so that of H, that of N, and that of 3 times O, that of O. So H is 1 plus N is 14 plus 3 times oxygen is 16. Okay, so this will give us 63 gram per dm cube. Sorry, molar mass is gram per mole. So this is 63 gram per mole. Okay, so we already know our molar concentration from here. Sorry, this is for B. This is for our B is B. Okay, so but for our A, we already know our molar concentration, which is molar concentration equals 0.1042 mole per dm cube. Okay, so this is straightforward already. So from this equation, we see that mass concentration is equal to molar mass times molar concentration times molar mass. So we have molar concentration is 0.1042 mole per dm cube. So times our molar mass, which is 63 grams per mole. Okay, so this will give us 6.56, if you multiply it together, gram per dm cube. Okay, so that's the solution for the equation. Make sure you subscribe, like, share with your friends.